Right guys, now let's see how to make more problems in differentiation, that is using substitution method. Using the next identity, I would like to use sine 2 theta. Alright, so the formula says 2 sine theta into cos theta. How is this formula basically formed? We know that sine of a plus b, right? Sine of a plus b is what exactly? It is sine a cos b plus cos a sine b, and from here I can see that if I can write b as a, I'll get what? Sine of a plus a, and that becomes sine 2a, and you get sine a cos a plus cos a and sine a again. So that looks like 2 times sine a into cos a, and that is basically sine 2a. Now we have this formula basically, or if I'm using sine 2 theta, it becomes 2 sine theta cos theta, right? That's the formula basically, right? Now can I make a formula or problem from this identity in inverse trigonometric substitution problems of differentiation? We'll see. Look at this. Can I put sine on the other side? I'll get 2 theta is what? Sine inverse of, yes, I can write 2 sine theta into cos theta. Now that's how it works. All right, now if I say theta is, let's say y is equal to sine inverse of 2 sine theta into cos theta. Now I need to make something out of this problem, right? So if my question was y is equal to sine inverse, let me take this whole thing as y. Okay, now simple thing, if y is equal to sine inverse of this problem, can I have, let's say, 2 into something called x into root of 1 minus x squared. Now see what happens. Why am I doing this? Because I'm writing cos theta as, let's say, I can write 1 minus sine squared theta is cos theta, right? So if it is root of 1 minus sine squared theta, it becomes cos theta. The same thing. So now I can see that this, let's say this is sine theta itself. Okay, the same problem I'm writing cos theta as root of 1 minus sine squared. So it is sine inverse of 2 times sine theta, and instead of sine theta, if I just take x and root of 1 minus x squared. Now if this is your question, okay, in inverse trigonometric functions of let's say problems on differentiation, all right? Now if that is my question, how will I solve this guy? Because all this is not given to me. I arrived to this from a formula of trigonometry with this guy, right? Now I'm just given y is equal to sine inverse of 2 times x root of 1 minus x squared. So how would I think of any substitution? The first thing to remember, as we discussed, is this whole thing has to become sine. This whole thing has to become sine theta or sine 2 theta, whatever it is, so that I can cancel this sine inverse and that sine. So it has to be sine inverse of something in terms of sine and whatever it is. Okay, this will cancel out. How can I make this whole thing as sine is the whole point. Now I can see that if 2 comes and 2 functions come, I can remember the formula 2 sine theta cos theta, or I'm telling you that that's how they made this problem, right? First they knew what is a formula, that is trigonometric identity. From this they made this problem. So we just learned this. How will we go back again? If I can use x as sine theta, see what happens. I don't know anything of these guys, right? So let's say I don't know these guys, all right? I don't know anything of these. So how do I solve this problem? If I just take x as sine theta, so what happens? Sine inverse of 2 sine theta into root of 1 minus sine squared theta. Yes. Now again, y is equal to sine inverse of, see, my whole intention is to make this inside bracket thingy as sine into whatever function, right? So can I write this as 2 sine theta again? Yes. Into what is 1 minus sine squared theta is root cos squared theta. And see what happens here. Y is equal to sine inverse of 2 sine theta into cos theta. And this looks like what? This simply looks like sine 2 theta. So my problem becomes y is equal to sine inverse of root of, or no root here, sine inverse of 2 times sine theta into cos theta is what? I can write sine 2 theta from where? From this problem, right? So now I can see that y is equal to, I can cancel these two guys and gives you 2 theta. What is the answer of this problem? Very simple. Who is theta? I got to put theta back in terms of x so that I can solve it. So here is where I took the substitution. X is sine theta, so what is theta? Theta is sine inverse of x. Now take this guy, put it there, that is sine inverse of x, and solve this guy. Y is equal to what? 2 differentiate this guy, dy by dx. 2 is a constant is out, and 1 by root of 1 minus x squared, and that is your answer. Alright, so we understand this very simple thing. Okay, so every problem which is made out of trigonometric identities, which I'm supposed to substitute something in terms of x and solve this guy, this is your substitution problems, right? So every problem like this has got an origin from the formulae. There are some special types of problems, we'll discuss them later, but most of them have an origin from one of the formulas of trigonometry. Okay, now come back to this. Can they complicate this problem a little more? This is the more general form of the problem in terms of sine 2 theta. There's only one type. We don't have to be working a lot on this. We just need to remember whenever you have sine inverse of, and there's a 2 and any function, and the square root of 1 minus that function whole squared. This is what I need to be remembering. If this comes, he's basically talking about sine 2 theta formula, and that's how it came up. Now, if they give you a question like, let's say y is equal to sine inverse of 2 times x root of 1 minus x squared. So basically, this is the problem, right? This is the problem. I solved it. Now, what if my problem is y is equal to sine inverse of 2 times, let's say, log x into root of 1 minus log x the whole squared. Now how will I solve this guy? That is too big to solve using chain rule. But can I use some substitution here? This guy looks exactly like this problem, right? So you have 2 times a function into square root of 1 minus the same function squared. So here what I can do is, let me do this second problem here. Again, my problem should become sine inside that bracket. Okay, it means whatever my question is, if sine inverse is outside, this whole thing has to become sine of something. All right, so based on that typical type, I should take what? Let me take the problem here. Y is equal to sine inverse of 2 times log x into root of 1 minus log x the whole squared. Now here I can see that if I can take log x as sine theta, all right, I'm just taking log x as sine theta, so that what happens to my problem? Y is equal to sine inverse 2 times sine theta into 1 minus sine theta the whole squared. See what happens here. It looks like sine inverse of 2 times sine theta into, this is nothing but root of cos square theta, and that looks like what? Sine inverse 2 times sine theta into cos theta. This looks simply like the formula here, 2 sine theta cos theta is sine 2 theta. So can I see that this whole thing is converted into y is equal to sine inverse of, this is nothing but sine of 2 theta. That's it. It has to become like that. Okay, all right, now what happens here? Next, I have sine inverse of sine. Okay, can I cancel this sine and sine inverse? Yes, I can cancel these guys and we'll get y is equal to 2 theta. Who's theta? Theta is back from here. I can get that, all right? So if I want to get theta, I just put sine on this side. So I get a sine inverse of log of x is theta. So use this theta in that part. So y is equal to sine inverse of log x, exactly, all right? Differentiate this guy, dy by dx is what? It goes like 1 by root of 1 minus log x the whole squared into differentiation log x is 1 by x. So that's my answer. Very simple. All right, now what if they ask you a different question? Let's say third question I'm taking, y is equal to sine inverse of, this design is same, the 2, and let me write anything here. Let's say tan x into root of 1 minus tan x the whole squared. So what do? I just take tan x as sine theta, and the same procedure follows. If the question is, let's say y is equal to sine inverse of 2 times e power x into root of 1 minus e power x the whole squared. So what is the question again? The same thing follows, all right? So if the third question is what I need to do, here I have what? I just have tan theta, tan x in this case, and this guy is tan x. I'm not even doing the problem once again. I'm just erasing log x from here and putting tan x. So what happens? My substitution becomes tan x is sine theta, and this is all the same because this guy becomes sine theta, this guy becomes sine square theta, and it goes till here, the same thing. And here, who's theta? theta comes from my substitution. So if at all I like sign on this side, this becomes tan x, and that is theta. All right. So here in this case, I'll get a tan x. And what is my answer? This becomes tan x the whole square into differentiation of tan x is what? It is secant squared x, and that's it. So I don't even have to do the problems again. I just need to know that what is the substitution and why this substitution. Just because I have this format, that is sine inverse of 2 times the function and the square root of 1 minus that function squared. If I know this format, all right, before we actually go to the exams, or if I know this thing and we have done problems over this, we can solve any number of problems which can be framed like that. All right, I hope you get this. Let's try doing the next type of formula and how to derive problems from that.